All right, section 12-3. Before we get started on that, let's take a look at what I've been promising you were going to have to do, and that was create a slideshow with the stuff you're making, these GeoGebra sketches you're making. So here's mine. Just what you can do is go to a drive and start a new slides, and I did it from a template. Pick whatever one you like, but I'll show you what it has to be in there. So pick any slide you like. Here's the one I picked. It's pretty simple because that way I can just put in, I know that pretty much every slide in this slideshow is going to have a GeoGebra sketch in it. So I just picked a simple one. I called it Circles Chapter 12, GeoGebra Portfolio. You should have your name in there. Let me add mine. All right. And then proceed to go through and put each of the images that you downloaded into this screen. So into this slideshow. So you're going to have 12-1 vocabulary, 12-2 vocabulary. For 12-1, we also started with a sketch where you're just playing around. If you like yours and it's fun, you can add it in here. It's not required because that was really just trying to get to know the program a little bit more. 12-2 vocabulary needs to be in there. And then 12-2 also had the arc addition postulate and the congruent central arcs and angles and chords, and then the radius as a perpendicular bisector to a chord. So those three sketches need to be in there. And then today we're going to do section 12-3. Now I want you to add one more thing. If I go to wherever I am in GeoGebra and I click, it should let me open the things I've already saved. Let's take a look. The radius, how about the congruent central angles? Yeah, that one I don't think I have yet. So if I open that and edit, I'll see it. I can move this around. And the whole point of this one was if I could get this number, DE, congruent to this number, CB, then the angles would also be the same. And that was what it was proving. 4.19, can I get it on both? There we go. And the angles are the same. And actually, if I go up here and do a distance or length and I click on D, it'll tell me, oh, it already did. Oh, the arc length there. And then I can move E and click on that and it will tell me that arc length as well. And so I'll notice that those are also the exact same arc length. So three things that are congruent. If one of those three things is congruent, then the other two are also congruent to each other. Angle to angle, chord length to chord length, arc length to arc length. Okay, so now I've saved this by doing an export image and downloading and congruent. So 12-2 is what I called it, congruent central angles and chords, Ms. Bien. I am going to open it. And now the other thing I can do that you haven't done before is I can share this and it will come up with this link. If I copy this link, I can now put this in my slideshow and it will bring me back to this live sketch and I'll be able to move these points around. All right, so I go to my slideshow and here is my arc. Now I'm going to go ahead because I added that extra little thing and insert image, upload from my computer. If you've put it in your drive, you can upload from your drive. And this one was my congruent central angles, chords, and arcs. So I click on it and click open, and it's in there. Now I want to go ahead and shorten it. It's got all this blank space on the side. So let me click on crop image and move it over a little bit. left and right. And that's just going to cut off this part here that sort of looks gray. I click on that again, and now it's cropped. I can make it a little bit bigger and just make it pretty. All right, so there it is. Now, I would also like to put that link in there, and I copied the link. So let me go ahead and do that. I'm going to add a text box, and I'm going to connect the link to the text box. So what do I want to write? I want to write, let's see, how about click to go to GeoGebra Live Sketch. Okay. Anything to get that across. And then I click on link here, and I can Control V to paste the link I copied. And if I had any trouble and it wasn't there anymore, I could always go back and click again and say share, and it would let me give me that link again. All right, so there we go. Go ahead and do that for the sketches you've already made. And now you need to make 2 more sketches for today. And the 2 sketches for today, it's sector area and arc length. So first I want to talk about arc length. Go back there. I have gone ahead trying to explain to you, and then you can explain it in your slideshow. We've already talked about the measure of an arc, and the measure of an arc is the central angle, but the arc length is the distance that the arc traces. So it's the fraction of the circumference. So we can talk about if it's, say, a quarter of a circle, that would be a 90-degree angle. So the measure of the arc would be 90 degrees. But the arc length would be a quarter of the way around. So whatever your circumference is, pi times diameter, or 2 times pi times the radius, a quarter of that would be the distance of your arc length. So to do the arc length, you have to know the radius, because you have to know how big the circle is. To do the measure of the arc, you don't have to know the radius, because it doesn't matter how big the circle is. It only matters about how big the angle is. Okay, so I've typed up a little something on those 2 there to explain it. Remember, this is going to be a slide presentation that you can pull out before you take the SATs and study up, or before you go take another math test sometime and study up on all the different properties of circles. So go ahead and put some explanations in there to make it clear later. And I am going to give you a grade on this, so it's worth your time. Okay, so go back here and let me start a new one. And I need a circle, and I need to show the arc, the measure of the arc compared to the measure of the arc length. Okay, so circle. Oops, no, I want this one. Make me a circle. There's 1 point. I'm going to add another point. I really only need 1 arc. All right, I'm going to show the angle. I go from center, and I go 1 to the, oops, did that wrong. Let me fix that. The angle, just the 3 points, 1, 2, 3. This one did it the way I didn't want. I do know the trick. If I do it in the other order, it will work. Otherwise, I could have right-clicked and changed it to be between 0 and 90 degrees. And then, you know what? I have this angle here, CAB. I want to change the color on that to make it more obvious. So I'm going to go with that bright green. Love the color. Oh, that's on that thing. And I can do it. So that's the measure of this angle here between these 3. I can define the circular arc. Select center and 2 points. Here's my center, here's my point 1, here's my point 2. That's D. I'm going to right click on that. Nope, didn't work. Oops. I'll do it over here. D. I'm going to click on the 3 dots, go to settings, change the color. Okay, now the measure of the arc BC is 73.1 degrees, but let me find the arc length. I do a distance or length, and I can actually just click on the D. It didn't take there. Arc length of D is 4.1. Now, it was based on the radius. So why don't we go ahead and find the radius? I'm going to add one more point so it's not too crazy. And then I'm going to find the radius between A and D. So measurement between A and D. DA is 3.22. So that arc length should be a fraction of the circle. Now, if I make this, let's see, the circumference, I can go over here and do it. Just type it in, circumference, a little hard to see. You'll be able to see it in a second. Circumference, and I'm going to say circumference A because it's for circle A equals, and I can just type it in. I can do pi, bring up the keyboard, pi times the radius, which is dA, and that's going to be saved in here. Wait a minute. Forget where it's saved. Oh, I think if I just type distance dA, okay, so that's the pi times this distance dA, so it's 2 pi times r, so times 2. Okay, so that's 20.21. That's the whole circumference. Okay, so if I say, well, what if I make this 90 degrees? Well, what if I make it 180 degrees? Well, let's try that, because then it's an easy check. 180 degrees. This says the circumference is 20.23. This says the arc length is 10.16. Sure enough, that's half of this. So the whole circumference, my arc length is half. Okay, let me undo that so I can move it somewhere else. How do I figure it out though when it's not half? Well, what I do is I figure out what fraction of the circle this is. All the way around is 360 degrees. So if this is how far the distance is in degrees, the measure of the angle, I do this number here, 73.1 or whatever that number is, divided by 360 degrees, and that will tell me the fraction of the circle. Then I multiply that times circumference. So my arc length, I'm going to say BC, equals the fraction of the circle. So I take alpha, okay, divided by 360 degrees, because that's how big the circle is all the way around. So if it's 180 degrees, it'll be half the circle, times, excuse me, times the circumference. So I can type in the words here, circum A, because that's what I've called it. Okay, and then it says it's 4.1, and sure enough, the arc length, according to the program, is 4.1. So over here, I've calculated the circumference and then the arc length using the equation out of the textbook, which you will see here. And that is that it's 2 pi r, and that's the circumference, times the fraction of the circle. So m is the measure of the angle of the arc using the central angle, and 360, of course, is how big the circle is. All right, so then that's another one of my that's another one of my GeoGebra sketches. I'm going to put that, save that, and put that and the link in my Google Slides presentation. And then I'm going to pause this because it's gotten long, and I will do the next one as a separate video.